presentation is can solar batteries and EVs, and by EVs I mean electric vehicles, disrupt energy industry? This is a very big question. And what is the key word? If you think what is the key word here, the key word is disruption. And therefore, we must understand the meaning of disruption in a much better sense than we usually do. In this presentation, I will talk about disruption. What is disruption? Energy storage, electric vehicles, self-driving cars, solar photovoltaic, and there will be some concluding thoughts in the end. You are free to interrupt me at any time with any kind of question. I take you to New York City, and the year is 1900. My question to you is, do you see a car? And usually, you know, I'll stop here for some time and people try to figure out where is the car. Of course, Avenue Street. The day is Easter. The year is either Easter Friday. The day is, and the year is 1900. And that's the situation of the Fifth Avenue in New York City. And you see one car, and most of the traffic is Ghoda Gadi. Now, 13 years later, is the same place, same day. Again, it is the Easter, and the year is 1913. My question to you is, do you see a horse? The answer is none. Now the question is, what has killed the horses over 13 years on the New York City, you know, the Fifth Avenue Street? The answer is disruption, is a technological disruption. Now, I will give you a couple of more examples, which I'm sure that people will be able to appreciate. So I'm moving from the last century to the present century. Many of you have heard of Kodak. And in the 21st century, in year 2000, the Kodak financials were 14 billion in revenue, 2.2 billion operating earnings.
Speaker left link.
So I was saying that the Kodak, and you know they are into the film photography. They were rather into the film photography. In year 2000, 20 years ago from now, they had 14 billion in revenues. And 12 years later, that is 2012, 8 years ago, they filed for bankruptcy. Why? Because they could not cope up with the business. And you see, they were in the film photography. They used to make film camera. And they are the one who invented digital camera, and they invented in the middle of 70s, in the mid of 70s. So why they failed to catch up the imagination that it is the digital camera that is going to rule the market, not the film photography. They realized it pretty late. When they realized it, it was too late. They brought a business model which was not compatible. So, I mean, in the film camera, every time you printed a film, a picture, they made money. And they wanted a similar business model on the digital camera, as a result of which they could not survive and they had to wind up, in a period of 12 years. After this kind of, the digital camera being pronounced. You see it now, Arvind? Hello?
Yes, sir. It's
Hello?
coming.
It's okay?
It's okay.
Now, there is a company called Garmin. I don't know how many of have you heard of Garmin, but they were the leaders in the digital navigation equipment, GPS. Now, if you look at let me take another color of the ink color, and maybe the blue one. Now, this is the share price of the the Garmin. If you divide the whole curve, and the share price is from 2004 to 2015, then you find that this is one part and this is the other part. In the other part, the share price has been pretty flat. The company has not been doing well. So what exactly happened at this point in time? It is because of the Google Map driving directions API. The Google came up with the API, and as a result of which any mobile camera, sorry, not mobile camera, any mobile phone is a GPS. You can turn any mobile phone as a GPS. This resulted people not going to market to buy Garmin GPS. As a result of which the main product which Garmin has been manufacturing, that was the navigational equipment. Yeah, the sales dropped and the company could not do well. Now, energy industry is a $8 trillion industry. The next largest industry on earth is the food and beverage, which is 3.9 trillion, healthcare 2.3 trillion, and information technology, which is 2.2 trillion worldwide. Now, if you have to, how big is $8 trillion? If you have to compare with the GDP of a country, then after the US and China, the energy industry is the largest GDP. I mean, if there were a republic of energy somewhere with the $8 trillion GDP, then that would have been the third largest country in terms of the GDP. Every recession has been preceded by oil price hike. So when there has been, if you look at from 1970 to 2010, every oil price hike has resulted into a recession for some time. So energy, the point that I am making is that the energy is very relevant to the growth, and energy prices are very significant in terms of the global growth. Now, energy storage, battery storage cost prediction predicted to fall. There are three industries: energy, automotive, and IT. The intersection between among them is the battery, the energy storage. And that is why the three industries have been putting a lot of effort and money into the energy storage research. As a result of which the battery prices have been falling. The battery prices have been falling 16% on year-to-year basis. I'm connected. Professor Jain?
Yeah, connected, sir.
Okay. The energy prices have been, I think June does not have this kind of problem, that June gives some kind of indication
Sir.
that I think Google, Meet has to improve that way. If I'm disconnected, I cannot figure out I'm disconnected. So the energy, the battery prices have been falling 16% on year-to-year basis. Today, which is 2020, the cost of the battery is roughly $200 per kilowatt hour. And by 2024, it is supposed to be $100 per kilowatt hour. So every 4 years, the price is going to be half. Now, in this space, there is a particular mention of Elon Musk, and I'm sure that all of you have heard of. He's a South African-born Canadian-American businessman, engineer, innovator, and investor. He has many innovation and research to his credit. He is the CEO and CTO of SpaceX, CEO of product and product architect of Tesla Motors, chairman of Solar City. Now, he launched something called Tesla Powerwall, which I'm sure many of you have heard of. It's a battery system for home and business. Now, before the Tesla Powerwall was launched, the best battery on the market was a German battery from Sonnenspicer. Now let's compare the Sonnenspicer battery with the Tesla Powerwall. And I have compared a 10 kilowatt hour Tesla Powerwall with a 10.2 kilowatt hour of Sonnenspicer. Now let's look at the relevant comparison. In terms of the weight, the Tesla Powerwall is lighter, is 260 kg versus 100 kg. In terms of the volume, the Tesla Powerwall has a lower volume. And when it comes to the prices, the Tesla Powerwall is 1/3, less than 1/3 of the Sonnenspicer battery. So it's just one product launch that has slashed the battery prices by 1/3. So there is enough improvement for the battery prices. And catching this idea, Elon Musk has launched a Giza factory. This is the biggest battery factory in the world. By the way, if you look at how the battery industry they work, Typically, the lithium is mined in Chile, is transported to China. They process the lithium and manufacture the cells. Those cells are transported to many different countries and they assemble those cells into the battery. Now, in the supply chain, the Elon Musk says that if you create a huge battery factory and cut down the supply chain, then straight away you cut down the prices by 30%. That is one third. And catching this idea, he established a largest battery factory in Nevada, which is called Giza Factory. It's a 5 billion investment. 40 gigawatt hour of batteries will be produced every year. By the way, today, not today, a few years ago, if you summed up the total battery capacity of the world, it is the 50 gigawatt. So, almost double. He doubled the battery production capacity in the world. And those batteries are 30%, more than 30% cheaper. Now, there is a company called BYD, Build Your Dream. This is a company from China. It has a very wonderful name, Build Your Dream, but that's the name of the company. And they are the automobile manufacturer. Now they are getting into the rechargeable batteries. The Giza factory of the Tesla. And this factory was supposed to come online by 2020. I don't know what is the situation. I have not followed right now. But once this factory comes up, then the total capacity of the battery in the market is going to be 3 times what it was a few years ago. If it was X, then Giza factory made it 2X, and BYD factory is going to make it 3X. Now, if the supply chain, the supply and demand, if you go by a straight line method, if the supply becomes 3 times, then the prices has to fall by 1/3 in order to match the demand. So that is how the prices are falling. That was about the Giza factory. There are to come online by 2020. They were supposed to come online. Again, I have not followed at the moment because the world is not in the right shape. And in the whole game, you see the Apple, the Foxconn, LG, Samsung is another player. Dyson, by the way, Dyson is there now in the UK company. They manufacture home appliances and they have some presence in the Indian market as well. Nissan and many more here you can see. Now, often I get the question, lithium how abundantly lithium is available? Is lithium the scarce resource? In the world estimated today, the total capacity of the lithium, total reserve of the lithium is 13 million tons. Now, if you consider the blue area as 13 million tons, then you just need half a million ton to power the whole world, and which is shown in the red area. So you can yourself see that it is a very tiny fraction of the total reserve of the lithium that is available to humankind, to mankind. and you just need a fraction of the reserve to power the whole world. Now, energy storage business model innovation. This is something which is particularly very interesting to power system engineers. There are two companies in the United States today. They are called Green Charge Networks and STEM. They have a very innovative business model. They go to the individual customer and they say that they will reduce the bill, the electricity bill, by some fraction. You don't have to pay anything. You just have to sign up a 10-year service with us, service contract with us. We will put up the battery free of cost at your location, and we will reduce your electricity bill. And we just need a cut in the savings that you incur. So this is a very innovative model. People don't have to pay out anything in the beginning. Zero money down. There is no down payment involved from the customer. They just have to provide the space to keep the battery. And their claim is that they can slash the bill by 10 to 50%. Now the storage disruption at the grid scale. You know, all of you know that there is very little amount of energy that you can store in the grid today, and that is mainly in the rotor as a flywheel. So all what you produce, that has to be consumed at the same time. So you can think of a supply chain which is just in time. You produce when you need it, really. At the same instant you produce, and at the same instant you consume. So that's the kind of supply chain the electric grid works today. I will now take a little detour and give you a very brief introduction to the load duration curve. I'm sure if you have studied power system planning, or if you teach power system planning, you must have heard of something called load duration curve. This is a very fancy name, but if you look at the X scale, X axis, then you see the number of hours. And if you look at the Y scale, you see the load. This number of hours, you can think of the hourly electricity requirement, and you order them from highest to lowest. So that is how you generate this curve. This curve simply means, by the way, the end of this curve is 365 into 24. There are 365 days and 24 hours in a day. So in terms of the number of hours, this should be, the last point should be the 365 into 24. And it simply means that the load on the system that was there for 365 days, that was this much. Sorry, I'm not able to draw a straight line. That was somewhere this much. So if you take 1000 hours, which is here, it simply means in a year, for 1000 hours, there was a load of 9000 megawatts. So if you look at 500 hours, or maybe a little more, a little less, then you see that on the system there was a load of 1200 megawatt, and that was for a very small period of time in a year. I mean, if you look at the graph here, I mean the table here, then there was a load of 189, 1301 to 1300, 13,001 to 13,189 for 7 hours only in a year. And since the supply has to match the demand, you have to install, the installed capacity has to be a minimum of 13,189 megawatt. So in terms of the utilization, you are using last 189 megawatt just for 7 hours in a year. But you have to have that kind of installed capacity in order to be able to meet the demand. What I'm saying is that if you typically do the analysis is from the previous example, then around 32% of the generation assets, they are utilized for less than 6% of the time in a year. And the rest of the time, that is 94% of the time in a year, they are sitting idle, doing nothing. So it's a huge investment that you have logged in. If you look at the last 189 megawatt, that is used 7 hours, which is 0.08%. But they have to be sitting there doing nothing for rest of the year. 1 gigawatt, 29 hours in a year. So 0.33% of the time in a year you are using. The rest, 99.66% of the time, not 66, I think, yeah, you are not using them. The next 1 gigawatt, 120 hours. The point that I am making is that the peaking power is very, very expensive. And in order to be able to supply the peaking power, the investment, you have to make huge investment, and the peaking power, the peakers, they have to sit idle for most of the year doing nothing. Now, the message that is I'm trying to give you is billions of dollars in generating assets used for only few hours in a year, and therefore there is a better way you can manage, and that is by implying the energy storage, and that is the batteries. The peaking power will be obsolete in a few years from now. If you are doing some research in power system planning, or you are looking for peakers, just do a Google search in a Google Scholar, the death of peakers, something, or the peakers will be dying, something like that, and then you will get number of the publications. Yeah. Any questions so far, Professor Jain?
Yeah.
I'm connected. Any questions so far?
Welcome.
Any questions so far?
If anyone having any query or question, please may ask.
Is it slow or fast? How?
Even pace. Pace is even, sir.
Okay. So no questions.
No one is asking right now.
Okay. I proceed and then take questions later.
Sure.
No issues. You can collect the questions.
Yeah, sir.
Electric vehicle. By the way, what role will car have in future? The per capita vehicle miles of travel is falling. And this is a trend from the world. People are not driving much. If you look at the black curve, the per capita vehicle miles that has peaked out. People are not driving much. The newer generation is becoming environmental conscious. It was a time when people had 3 cars, one for going to city center, the other for going to office, the third for going to, on a vacation, for a long drive with family, a huge one. So those were the situation some time back in the society. This trend is changing now, and there are many parts in the world where the car sales are declining, and in Australia, car sales are half today than what it used to be 10 years ago in a highly urbanized places. By the way, the Tesla Motors in 2003, it is the company is incorporated in 2003, and they introduced electric car. The Tesla car is more efficient. It's because the electric motor, the efficiency of the electric motor is roughly 95%. And the IC engine is 17 to 20%, which is roughly 5 times more efficient compared to the IC. Cheaper fuel. The Tesla car is cheaper to drive. It's 10 times cheaper. I have the data with me, and if somebody is interested, I can discuss, the calculations. But then they have to contact me separately. The Tesla car has fewer moving parts. By the way, it's a good question for those who drive classic car today, the IC engine-based car. How many moving parts are there in the car? Is more than 2,000. Is a number which is mind-boggling. Tesla car has just 18 moving parts. Now, what kind of guarantee you get on your car today is like X kilometer or 1 year, whatever happens first. And this block is repeated 3 times.
Yeah, sir.
Am I right?
Yes, sir.
Professor Jain? But what kind of guarantee you get on the Tesla car? Is infinite mile, 8 years. So within 8 years, you can go to moon and come back, and you can do it several times. As long as you do it within 8 years, you are still under guarantee. The question is why? What enables Tesla car or any electric car to give you that kind of guarantee? The failure rate of any product is linked to the moving component. If the product has more moving components, then the chances of failure, the failure rate of that product is higher. This is common sense. Since Tesla car has only 18 moving parts, the company can afford to give you that kind of guarantee. You drive infinite miles till 8 years and you are still under guarantee. Instant torque. 0 to 60 miles per hour, which is 0 to 100 kilometers per hour in 2.8 seconds. Wireless charging, inductive power transfer technology they are using. By the way, if you have questions, if people have questions, then I can answer many more. I can reveal many more facts about them. The projected cost of electric vehicle with 200-mile range a few years ago was in 2018, it was roughly 30,000, and most of the products, that is JV Volt EV, they were launched for 37,500 US dollar. The Tesla Model 3 unsubsidized cost is 35,000 US dollar. It is a semi-autonomous. It can go up to 250 miles and 0 to speed 2 in less than 6 seconds. The Foxconn. Foxconn is the company, they assemble your iPhone in China. They are going to enter into the electric vehicle market, and they are targeting to build electric vehicle for 15,000 US dollar. Xiaomi, they are going to build a small electric vehicle for $6,400. Now the business model innovation. So what kind of changes you think electric vehicle will bring in the society? First of all, you see huge charging stations today. I'm sorry, not charging stations, the petroleum stations today. So I often used to get questions, and I still get questions. What kind of, the charging today, people have to stand half an hour to an hour in queue to get, petrol filled in their car today in Delhi. I have experienced this kind of, the log jam there. So if the electric vehicle comes, what kind of, the problem will be there when it comes to the charging? By the way, you don't need a fuel station or a charging station. Any home, any house where there is a plug, there is a socket, there is an outlet, that's a charging station. So when you are driving, you just need an app to know where is the next charging station, where is the next home you can go and get your car charged and have a cup of coffee. Based on this concept, this idea, the Renault launched a Airbnb, similar to Airbnb, which is the largest chain of hotel today. By the way, this is a Swedish innovation. So L means electricity, BNB. And this simply means that the Renault will supply the charging kit to individual people, individual people like you and me, if they are ready to offer this kind of service. And all what you need is that your address should be registered on an app, and if anybody is driving by, they can stop by your home and have the vehicle charged and pay you. That's it. So you don't need a charging station, the kind of gasoline stations you have today, where the gasoline is stored. The huge infrastructure, you don't need that kind of infrastructure. Now there are many other business models. The Nissan and Tesla, they have set up charging stations along the roads. In United States and also in Norway, they are doing it. Because in Norway, the Tesla car is the most popular car in Norway. where along the road they have the charging stations and they charge your car for free. You stop there, put your car in a charging mode, go and relax, go around, and after half an hour the car is charged. There are many more innovations in this line. The Silicon Valley startup Volta offering free EV charging in exchange for media rights at prime value properties. So if you go to supermarket, you get a free charging, you park your car, you get free parking, free charging, and in lieu of that you have to watch the ads. So those places are full of the advertisements. You watch the ad, and in lieu of which your car will be charged for free. Now, as a power system engineer, you should see the electric vehicle as a power plant on wheels. Nothing more, nothing less. It's a source of energy which is moving, and yeah, it's a power plant on wheel. Now, think about the storage in the grid. I take you to Singapore. And this is pretty interesting, details. The Singapore can be powered for 6 hours on the electric car. Suppose all the cars, I give you the statistics. There are 600,000 electric vehicles, 600,000 cars in Singapore. Now suppose all cars, they become electric vehicle. And on an average, each one of them is powered by a 50 kilowatt hour of battery. Okay. So, and in 2014, Singapore consumed 44,923 gigawatt hour of energy. Okay. Now 30 gigawatt hour of the storage you have, you can power Singapore for 6 hours. A very rough calculation. So think the amount of energy storage you have, distributed energy storage you have in the grid. There is a company called Enel, which is the utility in UK, and Nissan is a car manufacturer. They have come up with a vehicle to grid project in the UK. And under this scheme, Enel and Nissan, they have tied up. The Enel will place a demand for energy on the Nissan, and Nissan knows where your vehicle is parked and at what point you can supply and what is the status of the charge of your vehicle. So how much energy you can supply. And you have, of course, you have to make an agreement with the Nissan, and Nissan can confirm Enel that this much energy Nissan can deliver at this particular location. So Enel and Nissan, they are trading this electricity, and this is happening today. By the way, you will get paid for giving energy to Enel. If you read McKinsey and many other reports and look into the energy future, by 2030, the gasoline, diesel to be obsolete. And by 2025, it will peak out. It will hit the peak, and then the production of the gasoline will decline. Any questions so far?
Please ask.
Sir, can you please elaborate about how electric vehicles are cheaper in terms of fuel than gas?
Uh, in terms of the fuel,
Yes, sir.
I think I can, but then I have to go out of this sliding, this PowerPoint mode. I will come back to this. Please keep this question and then I will come back.
Okay, sir.
Okay, sir. Okay.
Yeah. Okay.
Hello, sir.
Any other question?
Hello, sir.
Yeah.
The Middle East country, the producer of oil and gasoline,
Okay.
they are also not supporting this production of electric vehicle and
By the way, the cheapest solar power plant is installed in Abu Dhabi,
this.
producing the cheapest. I will come. I have skipped. See, I have very less time, and I know this kind of problem will come. You know, the connection dropped and those things. And I think I have to finish by 1:10, 1:13, 1:15. How much? I have a deadline, 1:10. I don't know how much you can sustain, but you can discuss with me privately the cheapest power. I will come. I have the slides. I will show you later on, but keep this question for the time being.
Sir, sir.
Okay.
Okay.
So self-driving cars. You know, it is the Google who came up with the self-driving car. Now, the self-driving car will change everything. And when I say everything, then there are a couple of points that I would like to discuss and many more, which I have not listed here. It will make the journey safer because most of the car accidents that take place is due to the negligence of the driver. So that aspect is gone. Less space, parking space, or the road. And you are dealing with the drives. In the electric car, okay, now, I mean, the braking distance, what is the distance that you need to maintain between the two cars when you drive on the road? You have to maintain a distance such that the half mv square becomes 0. If you brake, okay, then it will take some time to burn that energy, and that energy is converted to heat today. I mean, there is no way you can convert this energy to something else. So conversion of half mv square to heat takes longer time. So you need to maintain longer distance between the two cars today. Now, if you can quickly bring this half mv square to 0, that means you can reduce the distance between the two cars. That means you can put the more car on the same road. And also when you park, you maintain space. You have the door has to open and those things. So the parking space also can be reduced with a self-driving car, which is software driven. The disability is no issues. A blind can drive, a child can drive. Time saving. Today when you drive, if you live in Delhi, I don't know, I live in Bhopal, and I used to, I think 45 minutes I have to spend one way, 1.5 hours in a day I have to spend in the car to go to office and come back. So that 1.5 hours can be used to do something else. No need to pass the driving test. The better utilization. By the way, typically the US statistics is that you use your private car 4% of the time. Only 4% of the time you use your car. 96% of the time your car is parked in a garage, in your garage, or in your office, or somewhere. Now think about the point of investment. After your house, car is the item that involves the huge investment after your house. So you made huge investment in a product that you use only 4% of the time in your life. Okay. And therefore, the investment in a car is a very bad idea. It has a very poor utilization, and this utilization factor can be enhanced, can be raised by the self-driving car. How? When you have reached your home or your office, your car can go and do something else. And this is the reason why Ola and Uber, they are making money. Because they have increased of course it's not the self-driving car, they are human driven, but by bringing in more number of bookings using, the app, the mobile app they have increased the utilization factor, and therefore they have reduced the cost of the return, they have increased the cost, the return on the investment. And that is how they are making money. The self-driving trucks will also be on the road. It is being tested. Now, if you go to Singapore, you can take a ride in a self-driving taxi. It is already there. In a couple of years back, I think 3-4 years back, it was introduced. There are 33 corporations working on the autonomous vehicle. And by the way, there is one from India, and that's the Tata Elxsi. Now, if you have to make an electric vehicle self-driving, what you need? You need the machine vision, and of course the computer and the software. But from the hardware perspective, you need the machine vision. And machine vision is called the LiDAR. Now, if I was giving this presentation in 2012, you would say that this man is crazy. Why? Because the self-driving car which Google introduced in 2012, the cost of that car was $150,000. And out of this cost of the self-driving car, the cost of the LiDAR was $70,000. So the cost of the machine vision was about half of the cost of the self-driving car that Google introduced. Half. Now look at the kind of innovation, the research that has gone into the LiDAR space. In 2013, the cost became $10,000 from $70,000. 2014, $1,000, a 10-time reduction in a year. 2015 to 2016, the cost dropped by a factor of 4, $250. Now, if you look at the journey from 2012 to 2016, do you see my slides? Jan? Professor Jan?
Yes, sir. Yes, sir.
Okay. So now if you see this slide, then from $70,000 to $250 today, maybe a little less. Today is 2020. Now think, I mean, this was covered on the IEEE spectrum, the $250 LiDAR. If you read IEEE spectrum, you must have seen this. Now, think about the cost. So what was not possible in 2012? I mean, if the same presentation I would have given in 2012, you would have called me crazy. Forget, this is not going to happen. But in 2016, this is possible because the cost has come down from 70,000 US dollar to 250, just 250 US dollar. Now let's go back to another, improvement in the technology. The world's first 1 teraflop computer in year 2000. The space requirement was 150 square meter. The power consumption of this computer was 850 kilowatt. And the cost of this computer was 46 million. In 2000. Now, around 2016, 2017, NVIDIA, you have heard of NVIDIA, and they came up with a Tegra X1, the X1 GPU processor is a 2.3 teraflop processor. The power requirement is 15 watt, just 15 watt, and the cost is $59. This processor has a capability to run deep learning software. It can run computer vision with advanced rendering, and it can be updated over the air. Now, think of a $59 processor and $250 LiDAR. Just think of the two components. Here comes a gentleman called George Hotz. His qualification is he is the first iPhone hacker, and he built a self-driving car in his garage. Now he is selling a kit, which is a hardware plus a software kit that can make any electric vehicle a self-driving car. And he is selling to automakers or directly to the consumers. And he is selling it for 1,000. Just $250 LiDAR and $59 processor. And he has come on Bloomberg television, and he has challenged Google and other automakers like Tesla to come and fight, fight with them on the price war. Now, all the money which Google has invested in the self-driving car, I mean, that's fine. They did it, and they did it for the first time. But just the cost perspective of the technology, the way the technology has improved and reduced the cost, especially the LiDAR and the processor, has enabled any entrepreneur like George Hotz to make any car self-driving and disrupt Google and Tesla. This is going to end in future the end of car ownership. Why would anybody own a car? The mobility on demand. Today, if you need the milk, you go to supermarket and buy the milk. You don't go and buy a cow and you don't keep a cow. The same way, if you have to go from place A to place B, it should be the mobility on demand. So the self-driving technology is going to make the car ride, the ownership of the car redundant, and the asset utilization will go up 10 to 20 times. So from 4%, it can go up to the 80%. By the way, Helsinki is one such country. They have a very ambitious plan to make the car ownership pointless in 10 years. And they are going to reorient the whole traffic in the Helsinki so that it will be unattractive for people to own a car. And that will make the private cars obsolete. Solar disruption. Well, photovoltaic requires no water like traditional energy sources. And if you look at the cost of the solar photovoltaic, in 1970, the cost of the solar photovoltaic was $100 per watt. It has been declining since then. And in 2020, the projected cost is 25 cents per watt. In 2018, the cost was 40 cents per watt. I cannot confirm you how far it has reached because I have not followed. This is a very disturbing time for the world. So maybe what was going to happen in 2020 may happen in 2021 or 2022. But this is the trend. As a researcher, as an engineer, you should be interested in the trend, where the world is going. It can happen today, it can happen a day before, or it can happen 2 days after. But this is going to happen. Now, what is driving the cost of photovoltaic panel down? The efficiency improvement, which is 3 to 4.5% per year for last 10 years, this has been happening. Economies of scale, production optimization. By the way, most of the solar panels,
Sir, sorry to interrupt.
they are being manufactured.
The screen is not visible, sir.
The screen is not visible. Is visible now?
And for me, it is visible.
Okay.
What about the others?
Is visible now?
Quite visible, sir.
Okay.
Yes, sir, it is visible.
Yes, sir, yes, sir.
It is visible.
Yes, it is visible.
It is visible, sir.
Okay. Okay, good.
That may be the individual's
How-
problem.
Okay, no issues. That can happen. Why there are a couple of things that has happened in the world. Now, if you look at the energy consumption of Iceland, then you will find that over the last 10-15 years, it has gone 3 times up. Why? Because they first utilized the geothermal, and the marginal cost of geothermal is 0. That enabled them to force the world to outsource many of the energy intensive processes to them. So most of the smelting of the aluminum, which is a very energy intensive process, manufacturing of the photovoltaic chips, and the panels, and the manufacturing of the other semiconductor chips, they are the very energy intensive processes. Now suddenly, as a result of a very cheap energy which is available in the Iceland, the world turned the eye towards them. The processes, the industry started moving towards Iceland. As a result of which, the renewable energy is producing the renewable energy, the photovoltaic panel, which is the renewable energy. The marginal cost is zero for the geothermal. The marginal cost is zero for the solar thermal. And that is why the energy requirement to produce the solar panels that is falling, and therefore the cost of the solar panel is falling. This is also one of the reasons. Now, if you read the newspaper, not the technical magazines, you will find that solar together with energy storage is cheaper in Australia. Now, the rooftop solar suffers another blow as utilities switch tariffs. The utilities have to compete with the rooftop solar power plant. And utilities are reducing the tariff. Why? There is something called grid defection. I mean, this is a word I have never heard of before in my life. I have been a power system engineer for more than 35 years. I have most of my life I have worked in field, dealt with the real engineer. But it's just for past few years I am hearing the term called grid defection. Grid defection means I can go and tell my grid operator, I don't need connection from you, please disconnect. So I'm defecting from the grid, going somewhere else. And this grid defection has already started in many countries, including Australia. Now the growth of solar photovoltaic may actually accelerate. The current growth is 43% per year. Now, if you keep on growing 43% on year-to-year basis, by 2030 you will hit a mark of 70,000 gigawatt. And that is all the energy you need to power the whole world. Now, I give you a data from the Germany. And that's the projection from, they have done it for 2012 to 2015. If you look at the private investors, the longer curve, the longer bar, which is the black one, 116 billion of euro is to be invested by the private investors. And private investor means you and me, those who have the rooftop solar. So the largest investment in the solar photovoltaic is going to come from the private investor, that is you and me. Now, let's look at the stock exchange, because the stock exchange is the place where they get the nerve. I mean, before the researchers get a nerve, they get it first. Now, have you heard of Warren Buffett? I'm sure yes. He has moved his 20 billion US dollar in the solar business because he sees a huge growth in the solar business and he wants to be a part of the growth. By the way, it was 100 gigawatt by 2022. I do not know what is happening, but this is dead. I can discuss why this is dead, but this is not going to happen. In 2018, I mean, the growth rate was good enough, but after 2018, in this country, the growth rate has fallen, and there is no way you can hit 100 gigawatt by 2022. I don't know what is happening. This is a different story. This is a specific to India, and you know much better than I do. Now, China to install 200 gigawatt solar by 2022. 2020. And they are targeting, 200 gigawatt, and Yeah, they are on the track, more or less. I have not followed what has happened in the pandemic period, but before that they have been on track. Now the grid parity in 80% of global market in 2018. The Deutsche Bank, if you look at the Deutsche Bank, is a German bank, and they come out with the economic outlook every year. If you look at the 2018 economic outlook, then they have projected that the grid parity, I hope you understand what is meant by the grid parity. 80% of the global market, the grid parity. Grid parity means the cost of electricity from the photovoltaic is equal to or less than the cost of electricity from your grid operator. Now, I said by 2020, the projected cost was $0.25, that is 25 cents a watt. And let's look at what will happen if you hit that cost. If you hit that cost, it's not the grid parity, it's the guard parity. I will explain what I mean by guard parity. By guard parity, I mean the cost of the rooftop solar. The electricity from the rooftop solar will be cheaper than the cost of the transmission. So even if the marginal cost, if you assume that your coal plants are giving you electricity for free, then the cost of bringing that electricity from the coal plant to your power point, so I mean to your home, is more than what the elect cost will be from the rooftop solar. And that is what I have tried to summarize in this curve. The cost of finance means the cost of the interest rate. Typically in the United States, the interest rate is is lower. So if you assume a typical interest rate 3 to 5% or 3 to in this range, the dotted line. Just a minute. In this range, then and 7 cents would be the cost of the transmission, roughly. So the cost of the electricity from the photovoltaic is 4 to 5 cents per kilowatt hour. And therefore, even if the cost of finance, the interest rate, they go up to the 10%, the cost of the electricity from your rooftop will be cheaper than the cost of the transmission. And that means the death of the centralized generation. They cannot compete. They will become obsolete. Oil, natural gas, nuclear, coal, they will be dead. Now somebody was asking me about the Middle East. I'm coming back to this question. This is in my presentation. Comparison of LCOA, levelized cost of electricity, oil versus photovoltaic. So few years ago, when I did this study, the cost of the electricity from the photovoltaic was 5.8 cents. This was many years ago. I mean, many years, at least 7-8 years ago. That time, 5.8 cents. And if you have to produce the electricity from the oil, so that the cost of the electricity is 5.8 cents per kilowatt hour, then the cost of the oil should be $10 a barrel. I have simplified my complete argument so that people understand. If the levelized cost of electricity is 5.8 cents per kilowatt hour, then photovoltaic has been giving you this the electricity at this rate. And if you want to get the electricity from the oil at that cost, so that the cost of the electricity from the oil is 5.8 cents, then cost of the oil must be $10 a barrel. Okay. Now, somebody asked me about the Middle East. In Abu Dhabi in 2016 only, this was the contracted, there was a contract, and the contract was a jaw-dropping cost of 2.42 cents per kilowatt hour. Now let's go back to the previous slide and just make it half, 2.42 cent. If the cost has to be less than half, then the price of the oil, assuming a very linear relationship, which is not linear, has to be less than $5 a barrel. Can you assume the oil will be selling less than $5 a barrel? Of course. I mean, in this pandemic period, the oil on, the oil exchange market, that hit a negative cost, but that was precisely another reason. Not the actual cost, that was precisely another reason because of which the cost of the oil was negative for a few hours. But can you imagine the cost of the oil become $5 or less a barrel? No, it will not be. And that is why the Middle East is worried. They are reorienting their economy. They know it's that sooner or later, the relevance of the oil is gone. And once the relevance of the oil is gone, their relevance will be gone. Now, some concluding thoughts. Today it is real. That is how you get your electricity. Now, when it comes to the coal, 70,000 people per year, they are killed in this country because of the pollution due to coal. When it comes to the indoor air pollution and carbon monoxide poisoning due to chulhas, 300,000 Indians die every year. That's the statistics. Cost of air pollution in India, if you estimate, in terms of the dollar, absolute terms, which is $40 billion, 3% of the GDP. And 1 billion plus people are connected to unreliable grid today. Now, coming back to again the coal power plant, is water constraining our energy future? The answer is yes. Coal is sucking China dry. In 1950, China has 50,000 rivers, and today they have only 27,000 rivers. So coal is sucking China dry, which is very clear. It is near Nagpur, and there is a power plant. By the way, there is a power plant, there is a coal, but there is no water. So you can't run the power plant some of the times in a year. I hope many of you know where Farakka is, because if you travel by train, from mainland India to, the northeastern part of India, you have to pass through Farakka. They have NTPC has a power plant there, and I think that was in 2015 or 2016. They have to cut down the production because the water level has gone down. And these are, the instances from India and China. There are many more instances. The coal, the electricity from the coal is a water guzzling business. It requires a lot of water. Now the traditional utilities, if you look at Europe, the traditional utilities are under pressure. Their margins are under pressure. Their revenues are under pressure. They are going down. The biggest utility in Germany, E.ON, is divesting fully from the centralized power plant. Now this is my last slide. And I will end by a quote from this gentleman who was the oil minister of Saudi Arabia in 1970s when the first oil crisis hit. And his statement was, the Stone Age did not end for lack of stone, and the oil age will end long before the world runs out of oil. Okay, this is my last slide. And if you have any, I think there were two questions. One was about the cost, why it is cheaper driving electric vehicle. And the other was about the Middle East. So I have answered the Middle East.
Sir, there is one more question.
Yeah, let me, yes, what is that?
Mr. Ramanand Paul, please ask. He wrote in the chat box, sir, actually.
No, I cannot see the chat book because I'm in the presentation mode. So,
Yeah.
just a minute. I think the Zoom has that kind of. Let me discard the changes which I have made and go back to the chat window. Let me. Yes. Where is the chat window?
No, sir, he is ready to ask. No issue, sir.
Yeah. You just pose the question.
Sir, my question is how self-driving car change
Yeah.
the existing scenario of transportation system of our country, and is it possible in India?
Yeah, you just need somebody to stand on television. Okay.
Yes, sir. Yes, sir.
8 o'clock in the evening and say that from 12 o'clock tonight,
Yes,
your
sir.
car will be invalid. You cannot drive and you have to buy a electric car. Okay. Self-driving electric car. So that is one way. The other way, it will automatically, the system will orient, the system will adjust. Okay. It looks, I mean, there are self-driving cars in, I mean, the taxis in Singapore and many other places, they are running. By the way, I mean, the regulation has to change. And this is not that easy as it looks, but eventually it will come.
Ramanand, you mute your mic. Ramanand.
There are self-driving cars and these transports running on the college campuses in United States, and even the Google campus they are running it. But there are many more. What will be the future of the insurance industry? Nobody, I mean, no researcher is looking at that, because I speak with researchers from all branches of knowledge like economics and finance and many other people, and nobody is looking at that. Of course, in United States they are looking at this, but in this country nobody is looking at that. And so eventually that will come. The system I mean, you have a dedicated corridor, the bus corridor, and those things. Eventually, you see, I have not. Let me go back to my presentation, and I show you something called. Just a minute. View slide sorter. Self-driving car. Okay. Now, the General Motors, they have already launched in a city in United States. I have cut down. By the way, in a survey, do you see my screen? My
Yes.
okay. The Brazil, India, and China. 70% of the Indians say that they get this. They are not money. Chinese 95% Brazilian. Now I think it makes sense. You see, look at this. The ride share. The GM have come up with something called ride share lift of autonomous car vehicles. Won't be to customers but to a ride share platform. It makes sense for General Motors. The 70% utilization in terms of the time, easier to build a car to work in city limits. And usually in the city limit, the speed is less than up to 20 mph. And this for them. By the way, the Tata and here, they never thought of they can no, they are listening of selling car. They never think of in terms of selling the mobility and demand or something else. So the mindset will change and eventually the possible and conventional at the moment, possible and plausible at the moment. Eventually that will come. I mean, if 20 years ago I had asked you what will be the telecom, the future of the telecom, and the future of the internet. Today you have the cheapest internet in the world. I mean, millions of people are, buying a smartphone and getting, online today in this country. So 20 years ago, 25 years ago, if I had asked you this question, perhaps you would have said, no, it will not be possible. Back to the cost aspect. Let me see if I have this cost aspect. Yes, I have. Now, if you drive If you drive, say, 5 years, consider a 5-year period, and drive 60,000 miles in 5 years, the typical cost of driving a SUV is $50,000 over 5 years. Now look at the cost. The EVs are 10 times cheaper to charge, and cost is 15,065, against 15,000. This Tesla Roadster is 4.6 miles per kilowatt hour. Average retail electricity is 0.12 cent. Sorry, 0.12 cent per unit. The cost for 5 years, you can, you have the miles. Yeah.
So regarding lithium-ion batteries, you said so many things. And
Yeah.
regarding battery factory, you said so many things, sir. But I have a question regarding quality
Yeah.
test. Sir, before dispatching any battery, we have to do some quality test, right?
Yes, those are specified, and I think I think 12. How much? You see, 50. The typical life of a car is 15 years.
Yes.
Okay, and Tesla has tries to optimize the battery for 15 years of lifetime. And assuming one charge and discharge per day and taking some factor, not every day will be charging and discharging fully. They have come up with, I don't know how much it works out roughly, I exactly don't remember. The number, I think 5,000 or 6,000 they are saying. You can work out how many days are in a 15 years. And they are putting some factors, 80 to 90%. Okay, you can find on their website,
Yes,
and
sir.
they guarantee, so many, so many charge cycle. The battery life is estimated in terms of the charge cycle, how many full charge and discharge you can do. Okay,
But comparing
so
to lithium,
they are guaranteeing that kind of batteries.
yes, sir. I got your point, sir. But comparing
Okay.
to lithium-ion batteries,
Yeah.
hydrogen fuel cells will
No, that's
give
not
the-
as cost effective as this one.
Oh,
Yeah.
efficiency wise, maybe
Why you are worried about the efficiency and efficiency? What is the round trip efficiency of the battery?
battery efficiency.
Do you have any idea? Round trip, charge and discharge,
Yes, sir.
more than 90%.
Yes, sir.
You will not get this efficiency with the hydrogen.
Thank you, sir.
Yeah, this stuff. As much as I know, and by the way, I have been away from these topics for last 5 years. I have been doing all kinds of bullshit in administration. Okay, but you will not get this kind of efficiency anywhere except the batteries. So if the efficiency is the point, then batteries win. The problem with the battery is the volume, the energy density, and that is where the gasoline wins today. And as of now, the chemistry is not moving that fast, and people have, the chemical property, the energy storage, the storage aspect, the energy density is challenging. That is where, but in future, whatever chemistry comes, to be successful in the market, they have to be better than the lithium ion battery.
Yes, sir.
What is available today. So I don't say the lithium ion battery is something that will continue to remain in charge of, the dominating the energy storage space. But whatever technology comes, that has to be better than this.
Absolutely, sir.
Yeah.
Thank you, sir.
Yeah.
So I think, sir, we can stop here. Sir.
Okay.
Okay. So, sir, thank you very much for delivering a very thought-provoking that lecture. I hope all the participants will drive and it will give the new direction for thinking, and they will be benefited from it. And once again, sir, I pay my sincere thanks for accepting our invitation and sparing your valuable time. And I hope when the pandemic situation will be over, you will visit my institute physically also.
Sure. Professor Jain, I will come to your institute. I was there some time back. I think that was 2016 or 2015.